Okay, so now we're going to practice naming and drawing the two carbonyl groups that are related, aldehydes and ketones. So when I say carbonyl, what I mean is a carbon with a double bond to an O, and it's attached to some stuff. So if it's an aldehyde, the aldehyde is on the end. You can tell from the E in the name. So one of those things that the carbon is attached to has to be an H for an aldehyde, which is on the end of a molecule. And if, so this is R1, R means anything, and if neither one of those things is an H, where R is not equal to H, and R1 is not equal to H, meaning it's in the middle, then that's called a ketone, and you can remember that because in the ketone, the double bond O is in the middle, like the O in ketone, and the E is on the end. Aldehydes on the end, ketones in the middle. Okay, but they're both from this related group, the carbonyl group, which is C double bond O, very important for biological molecules like carbohydrates, like proteins, like DNA, like lipids, etc. Okay, so for the aldehydes, let's practice that first. CH3, CHO. Okay, so this is always going to be on the end. And in this, if we were to draw this out, this carbon's obviously attached to there. So we have two carbons. The second carbon has an oxygen attached to it and another hydrogen. So I know that this is two bonds because if you try to draw it with one bond, then this doesn't really work. The oxygen's octet's not filled. The carbon doesn't have the correct number of bonds because there's only two things attached to it. So the only way that we could make this work is with a double bond right there. So that's where that came from. Let me remove that really quick. Oops, went too far. Okay. And the next thing we need to worry about is the longest chain. That's quite simple here. 1, 2. There's only two carbons here. So, and because we know that this is on the end, we really don't have to number it because the number is always going to be 1. 1's always going to be the loneliest and lowest number for aldehydes because by definition they're on the end. Because that H, there's the H. Okay, so the way that you name these is the longest name, and then there's two accepted nomenclatures is ending using AL as the ending as an aldehyde. But if we say that, like this would be ethanal, that sounds a lot like ethanol, which is an alcohol if you're talking. So another accepted name is ethanaldehyde. And so that's really kind of the preferred name. So just adding the whole word aldehyde to the end of the longest chain. So ethanal or ethanaldehyde. And if you say ethanaldehyde, everyone's always going to know exactly what you mean. You literally have the word aldehyde, and then ethan means, or eth means the two carbons, no extra double bonds in there. So that's how you do aldehydes. Let's try ketones next. So that's going to have the carbonyl group in the middle. CO, CH2, CH2, CH3. So what you're looking for is a CO. And notice there's no H's on this. There's no H's anywhere near this. It goes carbon, carbon, carbon. This doesn't have any H's on it. This one has H's, this one has H's, this one doesn't. Okay, so when we draw this out, CH3, and this has 1, 2, 3, 4, 5 carbons. 1, 2, 3, 4, 5 carbons here. This one has CH3, CO. If we only write one bond to the O here, the O is not happy, and this would need another H on there, which we do not have. So this has to be a double bond. Okay, and this is what this would look like, CH2, CH2, CH3. So for these, because this ketone could be in the middle, it could be over here, it could not be on the ends, because that would be an aldehyde, but this could be here or there on this molecule. We have to include the number, the lowest possible number, 1, 2, or Going the opposite way, 1, 2, 3, 4. 2 is lower than 4, 2 wins. So this is going to be 2, and then you name the longest group, and we're going to add the ending O-N-E. So the longest chain here is 5, so that's pent, penten, and then one. 2-pentanone. One means ketone, aldehyde means aldehyde. Lovely, simple, straightforward.